Alright, so today I'm going to show you how to calculate the determinant of a 3 by 3 matrix, and the way I'm going to do this is using the method of cofactors, I believe is the name of it. There's another way of doing it, but this is the way I've learned and the way that I've used for for this entire time. So to calculate the determinant of A, first you choose a base column, right? And so a column is obviously going horizontal. And personally, I always get the columns and rows confused, so I always think, column, horizontal. So there's three columns. There's column 1, ABC, column 2, DEF, and column 3, GHI. So normally, if you have a random matrix with all without zeros, you pick the first column because it's just easier to remember. But if you see any columns with zeros, you definitely pick those because it makes the calculations a lot faster. And if you have a matrix that has a column with all zeros, then that determinant is automatically zero for reasons that will be incredibly obvious very soon. So the second step is to take the first number in the column. So for example, we'll take the first number in the first column, which would be A in this case, and we isolate the corresponding cofactor matrix. So in order to do this, you recognize that the first number in the first column is actually contained in the first column and the first row, right? So what we do is we isolate the first column and the first row, and you can see that we get a 2 by 2 matrix. Now this is called the cofactor matrix for A. And so what you do is you take that and you multiply the result of the determinant of that cofactor matrix by A in this case. So for example, if you're talking about B, you realize that B is in the first column, second row. So you isolate the first column with the second row, and then you get the cofactor matrix for B is being DFGI. And then you just do the same thing. So for C, and if you had a number in the second column, so for example, the cofactor matrix of E, in this case, you realize that E is in the second column, second row, so you isolate the second column and you isolate the second row, right? And you get the cofactor matrix for E, which is ACGI, and then you calculate that determinant, multiply that determinant by E, and then you go to step 3, right? So step 3 is multiply that number with the determinant, like I just said, of the corresponding cofactor matrix, right? So if we go back to A, right, so we would have A times the determinant of the 2 by 2 matrix, which would be E times I minus F times H, right? And once you do that, you move on to the second number in the first column, right? So that would be B. And you basically, if you have a 3 by 3 matrix, you have three numbers in the column, so then you do that 3 times and you add or subtract those three numbers that you get based on, because you have to be careful of your signs based on this this little graph here, right? So or matrix. So for example, the first column, you would have, A would be positive, B would be negative, and C would be positive. If you're talking about the second column, D would be negative, E would be positive, and F would be negative. And then ultimately the third column is the same as the first column. All right, so I know this seems really confusing and you don't know what the hell's going on. That's fine. I'm going to do an example in another video.